Figure 16-68 shows a procedure for calculating and sizing the overcurrent protection device that would fall in line with a setting in 490.21c in the NEC. Now notice the loads and items that the control panel must control is the heating element loads at 50 amps, other loads 85 amps with an 85% duty cycle, and most of that is selected from 430.22e or other demand factors in Article 220. And then notice the largest motor is 22 amps, and then we have two motors at 15 amps each. Now with this information given in accordance with 430.110 of the NEC, then we can come up and do our calculation. 50 amps times 125%, the heating element load is 62.5. We have two motors, 15 amps each, at 2 times 100%, 30 amp. The largest motor at 125%, so that'd be 22 amps, and that'd be 27.5 after the math is performed. Then we'd have the 30 amps at 85%, and we'd come up with 25.5. When we total these loads, 145.5. If we selected an overcurrent device at 150 amps or a setting that did not exceed 409.21c, then the 150 amp protection ahead of these conductors, which would be 1 alt from our table 310.16, based upon 145 amps, and the 75-degree column, say, THWN copper conductors, would be 150 amp. And that's what this illustration 18-68 is illustrating. How to size the overcurrent protection device in accordance with 409.21c as in car.